Okay, so I haven't really seen any like detailed examples of EIGRP Stub. I mean, it's very basic and hard, but I wanted to create something and publish it really quick, just to show like how it's reacting using Wireshark and whatnot. So, so this is basically the lab that I created in GNS3. It's running VMs, um, and the the uh, the topology or the example is basically this router 10 is going to be running stub ERGRP stub. It's going to be the stub, and this is almost like the internet provider, where this is almost like inside the building in the client's. This is like the client's LAN switch. This could be like a 3560 or something like that, like a smaller edge switch. This is probably like an ASR, like your the clients, the customers, their main router before the internet. And this is probably like we could assume this is a like a subtenant switch or a router or something like that, smaller, 3560, 2960, or maybe like an 892, where this in fact is like an ASR, something powerful. And the reason why you want to do EIGRP stub on this guy here is because he doesn't want to respond back to every single query out from the internet, from the provider. This is the provider. You don't want to have your provider querying your router. This is if you're sharing layer 3 information in this type of way without like BGP. I mean, we're just testing EIGRP right now, the stub configuration. So let's say you are sharing routes using EIGRP with you and the provider, and you have all their, or you don't even have to do that. I mean, you could be like, this could be just one office, and then your main office is another location. Well, this branch office doesn't need to respond to every single query out from your main location or the provider or anything like that. So, and then you can see how I'm going to show you how the within this branch office, how like the subtenant switches and routers and equipment behind it, how they react and how they see the network when you have stub configured. Um, but the bottom line, like even going through the Cisco, the CCIE, the official certification guide, and you're reading all this stuff. I mean, they got a lot of text here, a lot of literature, but I mean, it's very simple. They're going through and saying like, when you configure the certain options for your EIGRP stub, then it reacts and it does certain things, which is true. All this is true, but I think like some of this stuff is a little redundant. It's not needed. They're saying like slightly off base, according to Cisco's documents, when for every single query that it sends out, it doesn't always receive a reply, and then it says it'll only. Basically, all this is saying that the stub configured router will only receive a reply when these options are configured, but that's exactly what it's intended on doing. Like, you're only going to receive a reply when you send out a query. Therefore, Cisco is correct. They're saying Cisco's wrong, but Cisco is actually correct. You're only going to receive when you configure these stub options, you only advertise certain networks. Therefore, you're only going to receive a reply. So the bottom line is that you configure the stub. Once you configure that stub option, then you're only going to advertise the networks that you specify in the stub option configuration. And then you're only going to receive reply on the networks you advertise. And also, you're not going to receive any type of queries out to the stub router asking for a different path or anything like that. So it kind of limits everything. So if we take a look at router 10, I'll show you the configuration that I have. Let's see, show run router EIGRP. I'm doing the EIGRP name mode. Advertising this on a network command, but I'm not actually. This is a loopback interface should be 1. This is router 10 loopback interface. This should be 1. Okay, yeah. So that's loopback interface 0, 1. Now I'm basically redistributing only loopback 0. And then, yeah, only loopback 0. That's the only thing that I'm redistributing. And therefore, make one minor adjustment. Let me see this here. Okay. So the only thing that I'm redistributing is loopback 0. And loopback 0 is what is this? What is loopback 0? What's the IP? Show run interface 0. It's 1.111. So I should receive shutdown. So I should receive a queries, or actually replies, because you're not going to receive a query when you have that stub configuration configured on the router. So this router 10 is not going to receive a query from router 3 or 11 asking what's better route to even that route that you're advertising. You'll only receive replies back from queries, anything like that. So to demonstrate this, like I said, I'm only advertising this out, and then the connected networks. So to demonstrate this, actually to show what the routes look like on this guy, what's in the database for EIGRP, if you take a look, all these networks here are all from throughout the entire lab, basically. Yeah, I'm getting everything. I'm receiving everything. So it can receive everything. The thing is what it advertises out to the world. So if we go on to router 3, and then, so you saw that, I used that network command to advertise loopback 1, which is 2.222.222.2, that network, right? But you won't actually see that network in this database on the adjacent router 3. It's not going to be there. The reason why? Because I have Stub configured, and it's only advertising the 11 network, the 1111. Yeah, this one here. So therefore, and then also let me show you this. So basically on router 11, if you take a look at its database, it's a lot limited. And this, like I said, this could be, this network here is the loopback interface directly connected, and then this is what's being advertised, EIGRP. So this is like the subtenant switch inside of the building, inside of some sort of branch network, what you want to have. Therefore, it doesn't receive a lot of information. A lot of the traffic is, the EIGRP communication is limited because your main router, the gateway border router, basically, is it has the stub configured on the branch location. So that's something that you actually want to do. So it's limited, right? Okay, so now what I'm going to do is I'm going to shut down. I'm going to shut down the loopback interface, and we'll look at Wireshark to see what actually happens. So let's take a look. Okay, so this Wireshark here is the I'm monitoring between these two routers here, just to show you like how other routers are basically handling noise from router 10. And then I'm monitoring this guy here. So if I shut down like any of these interfaces, even though router 10 knows about it, it's not going to receive a query from router 3. So an example, I log into, let's say router 2, and then shut down the interface. It's the loopback interface is 0, and it's that network. So when we shut it down, when I shut that down and look at Wireshark, which is over here, this Wireshark is basically this guy here. Okay, so I'm monitoring the connection between him and then him. So when I shut that down, I swivel over, and then what I see is this. What I see is a query. So this is like between the communication, normal communication, without stub involved at all. One query out, in that query is going to be like, you're going to see a metric of infinity and our infinite metric, and everything's infinite. And basically telling this router here is like, I don't know where the subnet is, and he's getting a reply back like, yep, I don't know where it's at either. So they're both going to drop this network from the database, and then eventually from the RIB. And that's how it works out there. So when we look at the communication between our router 3 and your stub configure router, nothing really happened. There's no query that it sent. It may have sent an update. It's saying, hey, drop. And this update, it's not even asking this route. That's the limitation that I was saying. It's not even, it's not going to query it. It's just going to say, hey, from .2, which is this interface, multicast, drop with an infinite metric, drop 2.2.2.2, and it just told it. It didn't even query. And that's the limitation out there that you want to have on your border gateway routers. There it is there. So for this network here. So that's that type of communication. And then and therefore within here, you're not going to receive any type of queries or anything like that. Your subtenant switches and routers inside of the branch office, this router 11 is not going to receive anything at all, which is a great thing. Therefore, you don't have to. All your routers don't need to be like ASRs. You know, you have like a 2960 switches, or 3550s or something like that within the building, and that'll work. Now. And then we could shut down this interface on router 10, and as a last test for this type of topic is just you go in and then you shut down, and this is that 11.11.11.11. When I shut that down, this is between R4 or router 4 and router 2. What you get is queries out and you get replies back. But then if you look at router 3, he's going to send a query out and he's going to receive a reply back. And just like it's stated in the book, a little bit excessively, stated in the book. So this is the query that is sent out saying, hey, this network is basically dead in the water, and then he does receive a reply back. In the book, I mean, they did mention that, but they're basically saying like Cisco's wrong by saying that you're only gonna they're saying basically that Cisco is wrong because Cisco is saying for every single query you're going to receive a response of a reply back message, but that is actually true because stub configured routers are only going to advertise networks that it's configured for, so therefore it's true. Anyway, query out or reply back, infinite. I'm going to drop that network from the database and then from the RIB. and then that's basically it about stub configure routers. Just use them on your borders and your main routers, and then you could configure how and what networks you want to advertise. You're basically like filtering out what networks you want to advertise to your subtenant switches, and therefore you're limiting the communication. That's exactly what a stub is. All right.